of day one of the inaugural Nuclear Energy Innovation Summit for Africa. The official hashtag that we're using is NEISA 2025. Appreciate those that have been tweeting, sending messages. There are lots of people that would have loved to be part of this event, but they're not here. When you share those messages online, then they get access to them. They will know what happened in this room. We had a wonderful opening ceremony. We had great speakers, incredible conversations, and I hope that you got to learn something. At the end of the day, I do hope that we will go back home different from the way we came in. Now we're going to move into one of the most dynamic sessions of this summit. And the title of this is SMR Spotlight, Innovations Powering the Future. This session will spotlight breakthrough innovations in small modular reactors and their transformative potential for Africa's energy landscape. We're going to hear from leading developers and technology pioneers showcasing the latest advancements in design, scalability, and deployment, and how these innovations can deliver reliable, flexible, and low-carbon solutions for both industrial and off-grid needs. Now, before we have that session kick off, let us set the stage with a short video for context.
In a world demanding cleaner, smarter energy, innovation is no longer optional. It's essential. Small modular reactors are at the cutting edge of nuclear technology. Compact, scalable, and efficient, they are built for the challenges of the 21st century. For Africa, SMRs offer a flexible path forward, bringing reliable, low-carbon energy to both high-demand industrial zones and remote off-grid regions. This session showcases the breakthroughs redefining what's possible, from cutting-edge design to fast, factory-based deployment and real-world scalability. Today, we spotlight the innovations ready to power Africa's future, cleanly, safely, and on Africa's terms. Technology, transformation, tomorrow.
Cleanly, safely, and on African terms. And now to facilitate this session, please join me in welcoming on stage Ryan Pickering from the U.S. Department of Energy.
Thank you so much. We have a lot to get through today, so I'd like to introduce Professor Eugene to give us an opening remarks about what's at stake and where we can go from here in Africa and around the world. Thank you, Professor.
Hello, everyone. I'd like to thank the organizers for not just for inviting me, but putting this wonderful show where all the main messages have already been delivered. That's a good news. Less good news is that I'm an engineer, so I'll have to show you some numbers. So be prepared for that. Is this the... Okay. So to set the stage, you came to this event, so I'm assuming that you already fans of nuclear power. Nevertheless, it's worthwhile going a little bit through the main features. It's not a surprise to anyone, but just to register that. So nuclear power is low carbon energy source. So worth stating that. I'm sure this is not a surprise to anyone. It has a tiny footprint. So enormous amount of electricity can be generated in a smallest area without interfering with nature and other human activities. It's predictable and will provide power when you need it, yet flexible when you want to accommodate fluctuations in power demand. Fuel costs are trivial. This may be a surprise to some of you, but for all practical purposes, fuel is not just abundant, but it's also extraordinarily cheap. So the cost of nuclear electricity is in capital cost of the power plant, not in the fuel. So, and has already been alluded in previous session, the costs of spent fuel management are also surprisingly small, and it is surprisingly safe proposition. So, however, everyone was waiting for however, it does have challenges. So arguably the biggest challenge of nuclear power is costs, of course. So this is where small modular reactors are coming in. So long construction times as a corollary of this. Heavy regulations have been mentioned. Despite the actual small cost of fuel and waste management, the public thinks it's very dangerous and the fuel is limited and very hard to manage. So traditionally, reactors were built to be larger and larger in pursuit of an economy of scale. So let's explore that concept a little bit. So what you see here is a marvel of engineering. This is a French / German design called EPR, which we're building in the UK at Hinkley Point C and hopefully soon at Sizewell. So numbers here are actually not that important, but the shape of that curve is important. It basically tells you that the bigger the power plant is, the cheaper it becomes. So this comes from the fact that there are multiple things you have to do, that costs that you have to incur regardless of the size of the plant, like qualification of the site or building a road that leads towards that site. You have to incur that cost regardless of the size of the power plant. Another thing I want you to note is that this curve is non-linear, so it kind of takes off at really small power sizes. So why would we contemplate smaller reactors and hoping that they will be any cheaper? So let's explore that a little bit. So one of the things that have been talked about previously is a shocking realization that costs of nuclear, because they are mostly costs of capital, hugely depend on financing. So this is Hinkley Point C, but other large reactors in the West have similar, or you can have similar observations. So the green piece of the pie is the interest on your loan or servicing the debt for the construction, which tells you one of the most straightforward ways of reducing the cost of nuclear is to have more creative financing with or without government support. Another observation which was also voiced is the fact that the cost of hardware, all the equipment and pipes and valves and pumps and heat exchangers, or the reactor pressure vessel and so forth, they are relatively small. They're roughly a quarter of total costs. So where are those costs, and why do they vary so much across the world? So two particular colors I want you to note here. One is productivity of labor in on-site construction, and another one so-called indirect costs. Another way of saying this is bureaucracy or administrative burden of some people do the welding and concrete pouring, but 5 people standing nearby and checking that this is done appropriately. Is this the most optimal way of doing this? I don't know. There are obviously other success stories. What you see here is comparison of nuclear costs in North America and Europe versus rest of the world, with no cutting corners here. These are the same technologies being compared. So bureaucracy and cost of capital are the two obvious things to watch. And because you need to borrow so much money for so long, why don't we try to borrow less money for a smaller project that gives you returns sooner. So that makes your interest payments smaller. So I thought small modular reactors idea go back to sort of early 2000s. This is produced by Westinghouse in the US. This curve, again, the familiar economy of scale, but I dug a bit deeper and discovered this paper from 1980s and published in British Nuclear Society Transactions or Journal of British Nuclear Society, which argues exact same thing. So by going smaller, less money to borrow, there's higher certainty for project development, but also an opportunity to move expensive labor on site to cheaper labor in factories where you have better control, more opportunities for learning and more opportunities for standardization and quality control. So all these ideas have been around for a while, and now we are, as sort of global nuclear industry, are trying to take advantage of those. So one of the key things in that pursuit is how modularizable the designs are. So absolutely key thing is so-called degree of modularization. So the more of the power plant components you can move from expensive site to cheap factory, the better. And it turns out the smaller the size, the more modules you can, or the larger the degree of modularization that you can achieve. So as you can see here, the larger that degree, the lower the curve of economy of scale becomes, and at some point it becomes nearly flat. So your cost of nuclear construction becomes sort of insensitive of the power or the size of the power plant. So if you apply all these concepts in chain, if you build small reactors the same way you build large reactors with lots of on-site labor, the first two bars compare one large reactor, which is shorter bar, and if you build that same capacity with several chunks of smaller size, but build in the same way, economy of scale tells you that cost will be much higher. Not double, but much higher. However, exploiting these opportunities for modularization, learning, standardization, not just manufacturing processes, but also regulatory processes, also has been said before, then applying those, you can reduce the cost to something that is actually even smaller than the large reactor, but inaccessible in a way, in the same way if you build something like an NEPR, which is sort of the standard way of doing things, at least in the West. So I want to leave you with a few key messages here. So first of all, SMRs as an economic proposition is a very attractive concept, and I'm very excited about this, and I think we all should be. Let's make a good example here in Africa pursuing this. So as I said, modularization is the key. It can be cost competitive with large light water reactors, but it will require a very highly optimized supply chain, which enables learning and economy of mass production to compensate for negative economy of scale. So again, that was said in the previous panel or fireside chat, that it may come as there's a slight tension here with the desire to bring jobs and localize as much of those construction or manufacturing activities locally. Where this sweet spot is, I don't know, but this is something for us to explore. We talked about financing costs and necessity of deploying these power plants on a large scale. So for the learning to materialize, for manifest itself, it needs a reasonable volume of production. You cannot learn from two plants. It needs to be 20 or more to make the the factory transition to factory manufacturing worthwhile. Couple words about microreactors, and I'm finishing here. So these are at the very extreme of the economy of scale curve. So they will really struggle to compete with large reactors, but they don't have to be. So these are designed or intended for off-grid operations, such as mining or islands or hard-to-get-to areas where the local construction can be absolutely minimized. So from bringing the power plant on site to electricity flowing out, that time shrinks enormously, and you don't have all the expensive grid connection costs as well, so it can be economic. And it can be also decommissioned and taken away. So I do see bright future for microreactors. Just finishing and re-emphasize, or cannot emphasize more, the importance of not just infrastructure, but human infrastructure. So this is arguably the longest lead item in any project. So good people or competence that is being brought on a large scale, so that, as we heard today, the market or the demand for electricity is unlimited in Africa, essentially. Whatever we, as an industry, can deliver, it will be happily taken away, but it cannot happen without thinking about human infrastructure, and we at Cambridge are working towards that. So I hope this sets the stage. You know what to ask our panelists, and I'll turn it back to Ryan. Thank you very much, and apologies for slight delay.
Thank you, Professor. Hello, everyone. My name is Ryan Pickering, and I'm from Berkeley, California. I am not here representing the US Department of Energy. My current work is focused on working with students, communities, and stakeholders around the world to plan the development of new nuclear infrastructure and facilities for the benefit of all people. As humanity rediscovers our love for nuclear energy, I want to thank our hosts from Rwanda Atomic Energy Board for bringing us all together here in Kigali to explore the opportunity ahead of us. I also want to recognize the leadership of African nations in championing peaceful nuclear science and setting a powerful example of how this technology can serve human health, drive development, and unlock shared prosperity. In this session, you'll hear from 4 of the world's leading small modular reactor developers. Each will have 7 minutes to pitch their technology that they're bringing into the world. And after that, I will pester them with some questions to keep things lively. So let's get started. Please join me in
Okay, it's clear. Okay. Good afternoon, ladies and gentlemen. My name is Chen from China National Nuclear Corporation. Today it is my great honor to illustrate, and I hope that our experience can offer the valuable insight for our Africa friends. My presentation 4 parts. The first part is about the brief introduction to CNC. CNC, founded in 1955, originally as the Ministry of China Nuclear Sector. With the 7-decade development, CNC growing to the global leader with a total asset of $200 billion and listed among the Fortune Global 500. The core strength of CNC relies on its fully integrated industrial chain from the field from the uranium exploration, the fuel fabrication, to the nuclear power plants, as well as the decommissioning and the red waste. In addition to support the China domestic nuclear growth, since CNC in the national division, we call it the CNC Overseas, also has been providing the global solutions for over 4 decades. And currently, CNC Overseas is actively engaging with more than 10 African countries for their nuclear goals. Let's go through the journey of China nuclear industry. It begins with the scientific research in 1950s and advanced with the concurrent deployment of our indigenous technology and the foreign technology, accelerated with our successful innovation, successful localization, and independent innovation. And especially, we achieved the major breakthrough on the Generation 3 technology, Generation 4, and as well as the small modular reactor and the fusion reactors. At the early stage, China nuclear program also faced a lot of challenges, such as the fragmented roadmap and dispersed resources. And in 1983, our government decided to unify our national nuclear strategy. We call it the three-phase roadmap. Guided by this roadmap, currently China has successfully developed the full spectral technology portfolio from the thermal reactor, the fast neutron reactor, and the fusion reactors. Currently, we are operating 58 reactors, and we are building 54 reactors with a total capacity of 125 gigawatts, making China ranking first in the world. Let's explore our core technologies. One large reactor and 2 small modular reactors. Besides that, China and CNC is conducting the research and development activities on other kind of technologies, such as the micro reactors and the floating reactors. The HTRPM is our first small modular reactor. It is the global first and only commercial Generation 4 high temperature gas cooling reactors. This reactor uses helium as the coolant, graphite as the moderator to achieve inherent safety. This reactor also adopts the module design to make its deployment more scalable and flexible and much more adaptable to the power grid. Let's look at the second MSR, ACB100. It is also the global first and the commercial land-based MSR currently under construction, and it is expected for the commercial operation in next year. For the international cooperation, CNC and IEA, we have signed the world first capacity building implementation agreement for MSRs in last year, and in this year, April, we all jointly launched the generic unity requirement for SMRs to offer a standard solution for the emerging countries. To support this effort, the CNC has developed the comprehensive training system that covering the full life cycle of from the setting to the operation and outage to support the safe and efficient and localized deployment of MSR worldwide. From the above, we can see it clear that the innovation is the core driving force for the nuclear power development in China. So let us unlock the secret of the successful innovation. It rests on the synergy among the industry, academia, and research institutes. We also emphasize the unity of the acknowledge and action. It means that we should try our best to turn our idea into the real and deliver the solutions. So the success is powered by our stable strategy and the collaborative innovation and industrial scalability. For Africa, today we also focus on how to deploy the nuclear energy in Africa. Here, I would like to propose. Time?
Thank you very much. Let's get into some questions.
Okay.
I'm here to hold everyone to their time commitment. CNNC is building the most nuclear reactors in the world. Congratulations, and thank you for your leadership. What makes CNNC's, yes. Hey, this is an incredible accomplishment. Thank you, Chen. Thank you for your leadership. What makes your product work for emerging markets like Africa?
Sorry, I didn't get it. What?
Specifically,
yeah.
You highlighted the ACP 100. How are you thinking about bringing this technology to Africa? And why does your technology work for a country like Rwanda?
Okay. From the name of the MSR, we can see that the small and module. Yeah, for African countries, especially for Rwanda, I think the most true context is about our power grid. Yeah, so the small it means small capacity can adapt to the small grid. This is the first, and the second is the small. It also means the small capital. We can call it upfront the capital. So for almost countries, I think the lower upfront cost can lower the entry barriers for the countries just like the Rwanda and other new African countries. And besides that, our African friends lag behind. We lag behind the first generation. We lag behind the second generation. And now, currently, the world is deploying the third generation and the fourth generation. So I think if our African country can catch up this opportunity for the emerging of the new technology, especially the generation fourth technologies, I think maybe in the future, our African countries could be the leading one on the new, the cutting edge technologies in, maybe the generation fourth technology, just like this. So I think this is opportunities for the future.
Thank you, Chen. And we were talking earlier about these opportunities, specifically in jobs in Africa. How can we localize the benefits to Africa instead of just shipping in a reactor? How can we see real society-wide opportunity through CNNC's platform?
Okay, I understand. So for capacity, I think capacity have the multifaceted meanings. The capacity, maybe the first we call we mentioned the human capacity. For the human, we have human capacity and also our technological capacity as well as the manufacturing capacity, and so for the human capacities, I think that CNC and our targeted countries can to expand the educational program. For example, for our children in China, our textbook also mentions the nuclear technology, the nuclear science. So that, and also our government also make the public a lot of public engagements and in the media to let our people know the benefit of the nuclear power and for the technological capacity. Just as I mentioned in my presentation, that the innovation is the core one. So for the technologicals, they have two sets. One set is you introduce the technology from the other countries to further your capacities, and another one is your self innovations. And so for the new emerging countries, I suggest that just like China, you use we call it the two legs. There are two legs for working, just like it also means in parallel. The parallel indigenous technology and the foreign technologies. And for the manufacturing, the government must have a plan to must have very dictated, very detailed plan for manufacturing capabilities, especially for the localization. For example, in China, when China introduces the foreign technology from other countries, and our government will emphasize this project be the self-reliance and self-innovation project. So when we introduce this project, and we also improve and enhance our manufacturing capacities. So
thank you, Chen. The two-leg approach, the incredible leadership. Everyone, please give a warm hand to CNNC.
Okay, thank you.
Okay, next up for our SMR dating game show, we have Dual Fluid. Thank you and welcome.
So, waiting for the slides. So, thank you very much, and it's an honor for me and for our company to talk on this audience and on these selected people here, and in particular in this beautiful country, Rwanda. So thank you very much. I start with our achievements so far and with the statement what we want to do here in Rwanda. And you see here on the right-hand side our so-called critical demonstration experiment. This will be the first reactor experiment with a new reactor design since 60 years worldwide. And we hope that we can and we will perform this experiment here in Rwanda, which would push Rwanda in particular to one of the most successful countries in nuclear technology. And this is a great opportunity for us and for the country Rwanda. And for this reason, we already 23, we signed a contract with the government of Rwanda. And, oh, thank you very much. This is a controller. With the government of Rwanda. And this contract contains these steps for a project together with RAEB. Representatives of RAEB are also here, in particular Fidel Ndahayo. And we are making lots of progress in the site licensing and in all the steps so far. I don't know how to proceed here, sorry. Oh, one back, please. Yeah, thank you. So I have to go a step back to explain more detailed the problem of today's nuclear reactors. And I partially agree with Professor Schwagerhaus with respect to the SMRs, but they also have problems in scaling. So the problem is, why is nuclear power still a niche product? And despite worldwide nuclear power plant construction sites, we are still at a 10% niche since decades, and this didn't actually change. And the reason is a lack of competitive edge compared with fossil-fired power plants. Yeah, it still can't really compete with them, even so nuclear has a million times higher energy density than coal-fired power plants or gas-fired power plants. So where is it coming from? Generation 3 and 4 can also not really change it. They have some improvements, but you have the scaling effect that particular SMRs can't do that, can't solve it. So for a real change and drastic reduction of energy generation costs, what we need is a groundbreaking innovation in nuclear technology, which uses the potential of nuclear energy by a factor higher. And dual fluid can provide this innovation, and it can be even implemented swiftly in a smart regulation environment. So here is a more detailed explanation where it comes from. It comes from the efficiency. So all that matters is efficiency. Efficiency in terms of the energy return on energy invested, which means the ratio of all energetic output of a power plant during its lifetime compared with the energy input, also during its lifetime, which means all including construction, deconstruction, the fuel procurement, everything. So it's a life cycle analysis. And if you compare the different technologies, wind and solar, coal, you see they are all small, but coal is what modern industries are running on right now. So 30, a factor of 30 is the comparison number. And you see that nuclear today is already higher. So it is better than coal, but not good enough. And dual fluid, our new reactor type, could go up to 800 and much more with a higher, with a bigger power plants, the DF-1500, up to EROI, or an efficiency of 5,000, which means you obtain 5,000 times the energy than you invested. So this would be a boost for the economy. So how can dual fluid achieve this breakthrough? Well, it's a simple principle, and it's patented in all nuclear generating countries. We have a fuel loop and we have a cooling loop, and both are intermingled in the reactor core. So everything is liquid fuel, liquid coolant, but the functions are separated, which is contrary to the molten salt reactor concept. So German engineers are working on this concept. The problem of today's reactor is a low power density. And with this dual fluid principle, we can achieve a higher power density, but the problem is that liquids require a higher temperature. And for dual fluid, it is not a problem because the reactor size shrinks by a factor of 10 in the volume. And this means you need everything 10 times less structural materials. And this means you can easily achieve that are known in the normal industry, but not so well known in nuclear industry. And this created the best efficient reactor ever. And you have an inherent passive safety by a self-regulation, because liquids are very strong reacting on temperature changes. So it's a demonstration experiment, lasts for 4 years, starting now when the investment comes, and in the middle the reactor becomes critical. But the creative part is the first part, the blue one, the CDE fabrication development, which requires only 15 million. And we are currently acquiring investments for this. Here is the overall long-term plan. So after the CDE phase comes the so-called Prometheus DF300 development for the first power reactor, the DF300 with 300 megawatt. And bigger models are coming afterwards. Here's an overview of the models we plan: the DF300, the DF1500 with 1,500 megawatt electrical power, and the DF30G with 30 gigawatt thermal power. So these are the models we plan to develop. You find us at the booth here next to REAP, and my name is Götz Ruprecht, and my colleague Armin Hucke, the main inventor, is also open for any questions. Thank you very much.
Thank you. What an incredible technology. And as a reminder to all of our attendees to visit these booths afterwards so that we can go very deep on the science. These are some tremendous educators, and we are putting them through the paces with such a short time period.
Thank you.
I am so impressed to see this timeline that you've co-created with Rwanda Atomic Energy Board. I'd love to hear more about what it's like to work with an energy board here in Africa.
You mean the next steps?
Yes, and how have you created these next steps with RIAB, and what does it look like to work with a nuclear promoter in Africa?
Yeah, so you know there are other projects in Rwanda. There is a research center planned. You see it on the website, beautiful pictures. And we will be close to this site, or in this site, with our first experiment. But later, it can be extended to a general research site. And if everything goes smoothly here with a CDE, with a critical demonstration experiment, of course, we will continue here with a DF300 development. It will be very challenging, but in 10 years, we could go to the serial production, maybe here in Rwanda, so it's not unlikely.
Thank you. And being from California, where nuclear is currently illegal, and in Germany, where we've phased out nuclear already, what insights do you have? What policy decisions can we make in this exciting moment to bring a more optimistic and functional energy policy platform to Rwanda, to Africa, and all these countries seeking abundant energy?
So you've been giving a perspective for getting, well, this is at the end a political decision how to do it. So we can only offer the technology, but what I would suggest is just bringing the technology forward. So if we all are sitting only on the computers and making drafts and schematics and designs, my impression is that too many companies are doing this. And you have to do the step to the hardware. You have really to build something, and the regulators have to be smart. They have to be fast. And this is something, the main reason we went to Rwanda is there are smart regulators here. So Rwanda calls itself proof of concept country, which is a great term, proof of concept country. And so far, they kept all promises. So you really feel that they want to do it here.
Incredible.
Yeah.
Yes, let's talk a little bit about the importance of actually building things. You know, for so long, I think the nuclear industry is criticized with good reason because we're sitting on our spreadsheets pontificating about these big ideas, and yet we have this incredible labor force that we're not yet engaging. We see that you have an experiment coming up here in Rwanda.
Yeah.
Tell us more about how you're thinking about breaking ground and pouring concrete and start that work of understanding and learning by doing.
Yes. Well, we have already a detailed plan with thousands of items, so we could start immediately with construction. I know that the World Bank just announced that they want to support nuclear, advanced small modular reactors. So this would definitely help in getting this faster forward. And well, I'm sure as soon as you see results, then of course you will get another push. So this would be the best motivation. And here in Rwanda, it can be done very fast. And this is what should be done also very fast to make the first steps here for development park.
Yes, we hope the World Bank is listening to this conference, and I think that Africa is making the world very proud right now to show how ready we are to expand into this. You know, as you go into rural areas and build these experiments, what's one sentence that you could tell a mayor or a minister of finance about your product, and how can we make this real to everyday Africans, everyday people around the world? What are we talking about here?
Well, the most important fact is once this concept goes into commercial development, you will have the cheapest energy ever. So you will have electricity generation below today's prices, even in modern or in industrial countries. And you will have, because it's a high temperature reactor, you also will have a hydrogen production and therefore synthetic fuels. And this means you can cover the entire transportation market completely with synthetic fuels based on nuclear power, which means no emissions anymore, and clean energy, and very, very cheap energy. And you know, the Stone Age didn't end because of lack of stones. it ended because they had something better.
Everyone,
Thank you
a
very
round of
much.
applause for dual
Thank you
fluid.
again.
I'd like to welcome to the stage Holtec International.
Good afternoon, ladies and gentlemen. On behalf of Holtec, well, my name is William Bizelon. First, let me introduce myself. On behalf of Holtec, it's my great pleasure across the continent. So as you may know, Holtec is a US-based company. It's the largest manufacturer and exporter of nuclear capital equipment in the US. We are a vertically integrated company. I mean, we design, we license, we manufacture, and we commission our product. So we deliver projects on a turnkey basis, and I think this is really important for newcomers countries, like African countries and like Rwanda. So just to go through a bit across our products, which are important, steam generators, feed water equipment. You have to know also that more than 40% of the spent fuel in the world is stored using Holtec technologies, and more than 60% in the US with dry storage and wet storage. We are using our three manufacturing plants in the US and one in India to manufacture our products, and many more are planned to serve, let's say, the demand of the SMR in North America and beyond, in Europe and in Africa. And we also own 4 nuclear sites in the US, including the sites of Palisades, where we will be restarting the large-scale 800 megawatts reactor by the end of this year, and that will be the place for the first of a kind of our SMR 300 dual unit to be commissioned by 2030. All of this will serve, let's say, the deployment of the SMR 300 on a turnkey basis. So this is a real project that will be built in Palisades for the first of a kind. So if we go more into the details about the technology, so this is a light water pressurized reactor. So 1,050 megawatts thermal, 320 megawatts electric net to the grid, so for a single unit. But our basic, let's say, our standard configuration will be the dual unit. It is designed for a lifetime of 80 years. It is a low-risk technology and a mature technology. So if we go through the key advantage of the SMR 300, because it leverages, well, Holtec and his partners, with the support of the DOE, the US Department of Energy, has invested more than $500 million for more than 10 years. It relies exclusively on proven technology, on light water pressurized technology with more than 40 or 50 years of experience. This is a walk-away safe reactor and Fukushima-proof because it is fully passive. It only has a fully passive safety system. It only relies on natural phenomena like gravity or natural convection. It is economical as well because it is the highest power density of any of the light water pressurized SMRs currently in the market, at least for the generation 3+. It is simplified because obviously for us, S of SMR is not only small, but it is also simple. So, I mean, we have dramatically decreased the number of safety features. Think about 80 safety features, sorry, for a large-scale reactor. In the SMR 300, it will be only 7, fully passive. We have a supply chain certainty. We are only using, let's say, proven components, including the fuel and the control road mechanism. I should have started by this, but as you can see, it is a two hot legs PWR with one single one-through steam generator and an integral pressurizer. And I would like to emphasize one important thing that is really interesting for Africa is that the SMR 300 is really flexible. I mean, flexible in terms of siting, because it can be deployed virtually anywhere, because it has wet and dry cooling options, so it can be deployed in any area using Holtec's proprietary air-cooled condenser. And it is also flexible in terms of application, because it can be combined with Holtec proprietary technology, the green boiler, which is a thermal storage and steam generator facility that eliminates the need of load following. where the applications like hydrogen production, mining, or industrial heat are required. I mean, you can burn the fuel efficiently, staying at 100% of the power of your SMR at all time, and leverage, let's say, the fluctuation of the demand for other processes. Yeah. So so Holtec has built a proven delivery team for its SMR 300. So obviously, we are providing the technology. We're also manufacturing the big components like the pressure vessel or the steam generator in our advanced manufacturing facility in the US, which is a dedicated plant for the SMR, for manufacturing the component of the SMR 300. We have partnered with Hyundai, which leverages more than 50 years of uninterrupted experience in construction of nuclear power plants. The last big success being, of course, the Baraka power plants in the Emirates. We have also partnered with Mitsubishi to deliver the MELTAC control system with the INC, which is licensed in the US and in use in Japan and in China. We have also partnered with Framatome for the 2 first cores of the reactor, which is a standard 17 by 17 fuel assembly. And also, as a commitment for local development, we will partner with local partners. About our licensing, well, we have been ongoing large regulatory, let's say, process with the US NRC for some years. So with topical reports, white papers, hundreds of pre-engagement meetings. We have incorporated the regulatory feedback during this process. So what you have to think is that this is a low-risk technology. I mean, we have leveraged all the feedback from the licensing, and we are following the two-part licensing process in the US, which gives us some flexibility, let's say, for the deployment and the construction. And we're also leveraging additional feedback from the engagement in the UK with the generic design assessment. And just to finalize my presentation, so we aim like a 10 gigawatt fleets of SMR 300 in the world by 2040, starting in North America, but well beyond, across Europe and Africa. And you have to remember that Palisades will be the first SMR in operation in the US by 2030. So looking forward to support Rwanda and Africa with our technology. So remember that we build things. We are not a paper company. We deliver turnkey project and make it simple. Thank you.
Thank you. Thank you so much. I saw the word local a lot on your presentation for a US-based international company. It's very welcome to see. How do you see localizing the opportunities and benefits of nuclear here in Africa with Holtec's solution?
Well, we will. I didn't have time to mention it, but in Palisades, for example, well, we have leveraged let's say the restart of the large-scale reactor in Palisades to, let's say, assemble dedicated workforce and leverage local workforce. So more than it will create more than 1,000 jobs in the site of Palisades. So I mean, this is really important when you go into the market. I mean, you have to incorporate training. Let's say we are developing simulators. We are dedicated to train operators through this simulator, and that's what we are doing in Palisades, and also for the SMR 300. That will be the first of a kind in Palisades. So we could do the same in Africa. Also, yes, of course, we are committed to expand our manufacturing capability, for example, depending on the market demand. I mean, we have like a strategy of regional hubs, we could say, to replicate the advanced manufacturing division facility that we have in the US, well, in Europe first, probably, and beyond. So just to serve the local demand and local jobs. That's important. I mean, we are not just delivering a reactor. We are contributing to local economy and local growth.
Thank you. And we see this reactor size of 320 megawatts, that's larger than some African country grids today. But I noticed thermal storage attached to your product. Can you talk more about thermal storage and how that's changing the way we think about the size of nuclear plants?
Yeah, of course. So the thermal storage that I mentioned is called the green boiler. So it's a proprietary Alltech technology, which is made of storage facility and steam generation facility, which can be deployed either independently or either in combination with the SMR 300. So for a large range of application that needs high pressure or high temperature steam, so like for hydrogen production, industrial process, mining, or the range is really wide. So it is made basically of ferrite, of a derivative of iron that can be sourced. Everything can be sourced locally. So this, once again, could be, let's say, an opportunity to develop, local resources and local workforce. It can be built really locally. We don't need to manufacture it in other countries. So this storage facility can be basically plugged in with the SMR 300. And when the demand is low with the SMR 300 in terms of electricity, you can divert part of the electricity to heat the green boiler or divert part of the steam directly and store it in the green boiler, and you can deliver it as needed for non-electrical applications or for electrical applications, of course, as well, if you want to regenerate, let's say, electricity with steam and a turbine after. So, the range of possibilities and opportunities combining these two Alltech technologies is really wide.
Fascinating. And finally, I see that you're going through the regulatory process of the US NRC, famously challenging process. How is Alltech thinking about regulatory processes? What other countries are you engaging in, and have you engaged any countries in Africa?
In Africa specifically not, but we have extensive, let's say, regulatory engagement, of course, in the US, but also, as I mentioned, in the UK, where we went through the first step of the generic design assessment and the fastest completed ever in history, and we are now deep into, let's say, phase 2 of this process. So it will give us some feedback, some other feedback from a different regulatory framework, let's say, to deploy more broadly our SMR 300. And as our distinguished speaker mentioned earlier, we have to build like a common regulatory framework, if possible, in Africa, and that will leverage, let's say, the best, in a pragmatic way, but the best of the practice of different, let's say, regulatory bodies. And with these two aspects, UK and the US, we can manage to incorporate some good feedback so that we could deploy it, the most globally as we can. And we also have some feedback from the Canadian regulatory authority as well.
Excellent. Thank you so much. Please, a round of applause.
Thank you very much.
And for our final speaker, we have welcome to the stage, Rosatom.
Good afternoon. Ladies and gentlemen, the global energy landscape is changing rapidly today, driven by the need of the clean, reliable, and flexible power solutions. In this era of transition, small modular reactors stand out of game-changing innovation, combining cutting-edge nuclear technology with exceptional flexibility. Unlike traditional large-scale nuclear power plant, SMR offer modularity, scalability, and faster deployment, making them of ideal diverse energy needs, from the remote site to turbine grids. Today, I present Rosatom leadership in the nuclear technology and our commitment to delivering to innovative, safe, and sustainability energy solution worldwide. As one as a global frontrunner, nuclear energy, Rosatom has consistently demonstrated strong economic performances, technological advantage, and proven test records for nuclear projects. For past 18 years, Rosatom has connected 18 power units, one half in Russia and one half abroad, making us only company on the world executing serial NPP international construction today. Our overseas portfolio includes more than 30 units across 10 countries, from large-scale NPPs and with VVR 1,200 reactors to cutting-edge small modular reactors, SMR. Our solutions are designed to meet diverse market needs, from large energy grids to small isolated systems. Rosatom designed NPP and adaptable for extreme weather, climate, and geological conditions, ensuring reliability anywhere in the world. Let's focus SMR solutions. To deliver maximum value for our partners, Rosatom provides a comprehensive, flexible, and integrated offer covering every stage of a nuclear project. Energy solution is core of the offer, is energy solution NPP, construction that complex and innovative but time-tested nuclear power plant technology. Apart from energy solution, the integrated offer covers the issue regarding effective project development, nuclear infrastructure development, ensuring responsible governance and regulatory frameworks, human resources, training highly qualified professionals to operate facility safely and efficiently, local industry involvement, partnering with domestic suppliers to boost national economics, full fuel cycle services guaranteed for fuel supply spent fuel and decommissioning, public acceptance, promoting awareness of nuclear energy benefit through transparency and education. Additionally, we offer extra services like feasibility studies, feasibility protection system, and carbon-free energy clusters, ensuring a seamless end-to-end partnerships. The global energy market shifting towards small modular reactor due of the flexibility, scalability, and cost efficiently. Rosatom with Rhythm 200N reactor deliver from our icebreaker reactor technology, deliver 110 megawatts of electricity with 60 years lifespan, 90+% availability, and 6-year fuel cycle. At Rosatom, safety is not subject for discussion. The Rhythm series incorporate active and passive safety system, depth measures, and resilience against extreme weather with normal risk and maximum protection. Our first of a kind SMR NPP with Rhythm reactor in Russia is going to launch to Yakutia region. Beyond Russia, we've signed our first export contract with NPP Uzbekistan for 110 megawatts SMR, 2 reactors, demonstrated global confidence on our technology. Starting from nuclear infrastructure, that core full set services and solution needs to ensure efficiently responsible governance and regulation for sustainable national power program development here. During the all years project development, Rosatom assists a raising public acceptance of nuclear power plant awareness of all benefits. We strongly believe that transparency and openness to all stakeholders is main tool. When it comes education and training, then diagram shows us the structure of education and training on personnel in Russia. On the left side, on the slide, in the school education, vocation education, and the consortium nuclear university, which includes about 20 of them. On the right side on the slide, Rosatom Technical Academy is responsible for training of operational personnel, and the Rosatom Corporate Academy, which is changing to the development of management comprehensive and soft skill. Rosatom is one of major global manufacturers for nuclear fuel. Rosatom has fuel cycle technology for production and nuclear fuel, from uranium mining and the fabrication of fuel assemblies. Our policy is fully provide to customer with reliable supplier of nuclear fuel. As of operational and services, Rosatom offer a range of maintenance services and overseas partner, including NPP operation management, including technical assistance during NPP commissioning, operation, and also arrangement and performance preventive maintenance, maintenance and repair services, NPP equipment lifecycle management, mining supply of equipment and spare parts during NPP commercial operation. And assist NPP repair document development. Rosatom provides different services on the field, on the track, on nuclear fuel contract, such spent fuel nuclear management and red waste management, and NPP decommissioning. In NPP decommissioning, Rosatom performs full range of work, decontamination, dismounting, and management generated radioactive waste. Rosatom also offers assistance in construction on final disposal facility and for the customer side, and red waste generated during operation decommissioning and spent fuel management, including red waste and SNF reprocessing. Rosatom involves local supplier for all our projects, fostering industrial growth and job creation. The level of participation depends on country industrial readiness, but our goal is always a boost expertise for economic development. Rosatom integrated offer also cover additional options, SMR and PP, such as pre-feasibility study development, physical protection system, and survey site selection. Such offer provide a comprehensive approach to project implementation and full range of product and services from the single supplier with significant expertise to ensure effectiveness project development. Nuclear power project is more than energy. It's a 60+ years partnerships with promote energy security, economic growth, and technological progress. Rosatom's commitment to being a reliable, responsible partner, offering flexible contracts customized to each nation's needs. Together we can build a sustainability carbon-free future. Thank you very much.
And with that, we are out of time. Please give another round of applause to all of our SMR vendors. Thank you again for your attention.
Thank you very much. Those were great presentations from SMR vendors, China National Nuclear Corporation Overseas Limited, Dual Fluid, Holtec International, and Rosatom. And thanks to Professor Eugene for the insights and Ryan Pickering for their facilitation. Now, earlier in the day, Dr. Zabo mentioned countries that will in a few years face exponentially high demands for power, including Rwanda. In fact, for Rwanda, he said it will be up to 4,008%. Now, you cannot meet such needs with only today's tools. These vendors that you have seen on stage are key figures in this journey. Thank you so much for being a wonderful audience so far. We are setting up for the experts panel that will be coming up in just a bit, and I'm looking forward to that. It will be delving deep into opportunities and challenges of nuclear energy adoption, a continuation of the discussions that have been seen on that stage since we started. There's a beautiful